I'm very happy that Katja is here. She's a PhD student in Deggendorf, was an exchange student once and took the course and already expressed in that time that you want to contribute. Now here the second time as a guest lecturer. So Katja will talk a bit about project management, life cycle of AI projects. And yeah, we're very happy that you're here today. Please go ahead.
Thank you. Hello, everybody. Let's start right after.
Yes, click once.
A little bit about me, as Professor Glöner already mentioned, I was an exchange student here. Currently, I'm pursuing my PhD. I'm the researcher in Technology Campus in Grafenau. My work experience is 4 years of teaching at the biggest university, one of the biggest university in Russia. I'm a software developer, senior database developer. And currently my research interests are knowledge extraction and formalization, companies' business processes, and optimization of integration external systems into the enterprise content management systems. Our plans for today is, first of all, take a look of software development lifecycle to talk about a little bit more why do we need this, how we can organize teamwork, and which are the approaches can be taken in the project management. We'll also talk about lean data science project management approach. This is a relatively new approach which has mostly used for data science projects. And we also talk about why it's different and why it should be different when from the regular management approaches. We'll also cover some tools and see approaches for extreme programming for side projects. So let's start from the software development lifecycle. On the slide, you can see very official definition of this term from the website of one of the biggest software project management companies. They're providing such tools as Jira. We will talk about a little bit later. So when you see this definition as a software development lifecycle is a well-structured process that guides software developers project start to finish, what do you think about? Why do we even need this? Please feel free to just speak up.
Otherwise, everybody just does what they want, and there's no real structure, or if you try to merge features, it ends in disaster.
And what do you think there's a goal from that?
To maintain the quality of the code and testability, maintainability, and to build bigger applications and scale applications.
That's right. And from this, do you think there is a one approach for every project can be the same, or there's it can vary?
You asked this question that way, then I think there's not one way to fit all.
So the software development lifecycle offers us a set of patterns how we can interfere with our project to be cost efficient, to start and finish on time, and to have more structure while developing. And as a result, we have a cost efficient product that can meet customer request. And meeting the customer request is the most valuable thing when you're developing any type of project. Let's take a look on the official diagram of this approach. What do you see here? Why do you think where is even the start of this circle?
If you start from nothing, then you would start at planning as a plan.
And on the planning stage, what do you think you need to?
Well, talk to the customer a lot, what he actually wants, derive requirements from that, and try to derive measures to fulfill these requirements.
And do you always know who is your customer?
Probably not.
For example, when you're working on a student project.
Well, then your customer's a professor.
When the professor doesn't give you any clear requirements, your requirements is just you should build a system which has a database.
I think we can make up an imaginary customer.
Okay. So you were right that we are starting at planning and not an analysis, but before even planning, we have an initial phase when we should ask ourselves these 3 questions: is why we are doing that, who we are accountable to, and how we're gonna manage it. So on this stage, we have we have to conduct a feasibility study. Do you have an idea what does it mean? No? Okay. On the presentation, there are clickable links. After it would be slides would be shared, you can read more. But briefly describe the feasibility study is basically that you're looking at your team and thinking, okay, I have this many of people, this competence. So only after that you can deep dive on what you're gonna create. So it doesn't really profitable to start, for example, some machine learning if you have only hardware guys on your team. So that's why we have to create a feasibility study. Then we need to have a project charter. The project charter is something that's built for from management team or one person if we are talking about a small student project. This is basically the document that officially kicks off our project. So we have a fixed starting date. There are outlined key tasks and key criteria when we're gonna stop. So basically the definition of done is briefly described in this document. Then we can identify the stakeholders. So the stakeholders is those people who are gonna provide more detailed request, and any tasks can be discussed with them. And in the very end of the initial phase, we need to choose the project management tools. And after that, we are moving to the planning of the development itself. So our 4 main questions on the stage of planning is what we are doing, who we are, how much does it cost, and when we need to deliver. Here we need to create the project resource plan, which came out from the feasibility study. So we have amount on this stage, we know the exact amount of people in a team. We can briefly outline how many people are we missing, who we need to hire or find. And also here we can briefly discuss with a customer the cost of this and conduct our budget. And only after that, there is a development stage. And how many of you ever tried to work in a company or startup or project when you need to not just do everything by yourself or in a small team at university, but somebody was giving you external tasks for development? Yeah, 2, 3, 4. Okay. So as I understand, now you are all doing the internship in a different companies. Have you already started and have you already seen how the management of the project works? Can somebody quickly share the experience of how many people on your team, how the communication is organized?
We did one project in one of the summer breaks or winter breaks, as we do a studio. And we were a group of 5, and we weren't that experienced in project management. We didn't really have a manager. We just organized ourselves. We got the assignment from our trainer, and we just had a Teams chat and a lot of calls and planned everything from there. But I think now we will do it with GitHub issues, GitHub project, and then you have everything in one place.
So when you're working without a clear manager on top of you, just with a brief outline of tasks that you need to fulfill, is it easy or not?
Depends on the team. I think if you get along with each other and if you can rely on your teammates, then it can work. It did work quite well. We were really happy with our structure, but I think if the project gets bigger or if everybody has other work to do, it would be better to have someone just responsible for organizing the project.
So have you delivered what you were supposed to deliver or not?
Well, the project was cancelled, but not without us. Our trainer left, and therefore the one that gave us the assignment, and it wasn't sure if the next trainer would take over, so it was cancelled. But it was looking really great.
Okay, so on the development stage, as you described, you have some criteria to meet. If the project should run till the end, you need to somehow control your progress. And basically, the project management question is how to control this. Deliverables, when to control them, and to find the balance between micromanagement when some manager contacts you on Teams 5 times a day asking for the update on that exact task, or just once every 2-week meeting when nothing is moving and you're just planning the next meeting. So on the control stage, we also need to discuss the resources and risks on our project. And we need to track the progress performance in the most effective way. And we also need to track the customer satisfaction. And the question is here, how often we can bother the customer? And is it necessary to do so to deliver the needed quality of the result? And there is 4 known approaches for the project management. As you can see on the screen, there is a frequency of delivery and degree of change. What does it mean? I think with the frequency of delivery, that's clear. Please raise your hand if I need to specify more on that. No? Okay. Then let's talk about degree of change. That basically means how different our project looks like from delivery to delivery. And if it's low, that means we either there's 2 options, not doing anything. And the second is our steps when we deliver is so small that the changes is nearly not visible at all. And high degree of change, that means we can go from nothing to all done project in a week, as it happens with the students' projects really often. Or we just planning to deliver one time. What do you think, which approach is better when we are talking about in these categories? That's nice silence, because each approach is very different to the task. And after we will deep dive in each from these approaches, we can discuss it again, because not every single approach project needs an agile. How many of you heard about this technique of project management? And have you heard about that agile is the future and everybody need to use it? Are you agree with this? No? Okay. Let's discuss about every of 4 known approaches and think about when we need which of them. First of all, the easiest one is with a very high degree of change with a very low amount of actual project deliverables. Deliveries, it's the predictive approach. When we first of all using our life cycle of software development and turning it to one string when we analyze, design, build our project, test it, and then ship to the customer. This approach had a lot of benefits, and it was used for a pretty long time. The most and the biggest benefit is you can calculate the costs very precise. So you always know how long it should take for design, for each step, and to deliver. Also, we don't have to change anything after it's done. And do you see any problems here? Let's think about that in this term, that you stated the requirements with your customer. You both signed it, and technically, when your project meets all the requirements, customer should pay you full and walk away. Do you think that's bad for you as a team?
No, it's bad for the customer.
Mm-hmm.
So I think he, after 1 or 2 times working like that, or giving an assignment like that, and when he gets it, it's not anymore what he wants now. He wouldn't give any more assignments. These kinds of software developments.
Mm-hmm. What do you see on this slide?
Well, the gap increases over time, and what the customer needs is, deviates more and more from what the developer builds.
Yeah, and I think it's not a big surprise actually that this expectation gap is always there in a software engineering, because the biggest problem is that customers don't actually know what they want. And if you are just a small team of passionate developers without business analysis or without requirement analysis, the special person for that, it's pretty complicated to get the exact information from the customer about what they want. And so every single team operates on predictive approach, face this problem. I cannot tell that it's always can be such a great gap between expectation and delivered thing, but in the most frequent way of operating the companies, it's usually the thing, because a lot of customers also operates as a service for somebody, and the requirements from their customer are different, so they need to provide this middleware, for example, service website differently, and now that's a problem of the team who need to development team who need to start this over and over again. And after that was decided from the project management board that we need a different approach, and there is an iterative approach. That's basically the thing when we are planning our initial cost, initial project, and after the planning phase, we iterate between implementation and testing. We're talking to the customer and deploy in the end. Do you see any improvement from the predictive approach?
It can change something, because you arrive again at the planning step, and you can change your requirements, and therefore your code and testing and so on.
Mm-hmm.
And you have feedback.
Mm-hmm. And when you are asking for the feedback, do you see here the actual feedback stage? So do you think there is any clear communication with the customer?
If there is, then it is a evaluation.
Mm-hmm. And if we are talking about the project with a lifespan of 3 is too much, 2 years, how often we need to communicate to the customer?
2 weeks.
Mm-hmm. So there is approximately 4 weeks in a month. so twice a month for 24 months. Do you think that here can be the problem that the customer would change the requirements every 2 weeks? And after that, on the last 4 sprints, for example, last 2 months of the project that was lasting for 2 years, you need to find yourself somewhere in the middle of the project, and it should be done with the last remaining sprints. And this is a problem because you cannot always calculate the exact costs. Because if the customer values the done project and not the completed work, they would rather pay more to the team and be not happy about that, or try to cut the costs by not implementing something. And here, why this approach is sometimes more challenging. Third approach is incremental approach. This is basically a lot of small predictive approaches combined together. The idea of incremental approach, and we have the brief description of the project. We divided it into the small blocks and trying to build each block with a predictive approach. So we getting to the customer, getting all the requirements, building it, delivering it, and only after that moving to the next block. So here we cannot loop for eternity in one spot, but also the customer has some control on the project because each block would be started from the analysis. And if we will think more into that, here the customer can leave the team at any point, because as soon as they are satisfied with the result, they can say, okay, this is done project, I'm happy with that, I'm paying only for that, and I'm leaving. Do you think that's fair to you as a team?
When you finish your work for this increment, at first sight, I don't see any disadvantages. But it's hard to plan your resources in advance.
Now let's think about these approaches on the idea that we're trying to build a picture of this nice man who's the author of a lot of books on project management. As you can see here, which approach do you think it is? When we're first sketching the outline, then we are building it and taking it in black and white and then painting with the colors. Are you sure? Do you see any?
This is the little picture, the little step. Like you increment on some color and then to more color.
But is it a have you seen on the middle picture some already finished block or finished part? We want to have exactly this picture.
Yeah,
Iterative? Yeah. And now this. Yeah. Now, do you understand? Who does not still does not understand the difference between incremental and iterative approach? Nobody. Okay. And now, what's that?
That's agile.
Exactly. Agile, it's the flexible approach that that help the teams in a very non-predefined fields to build a project, to communicate with the customer, and also to plan their resources in the most efficient way. And the agile, there is a word that was introduced with this technology, is a sprint. How many of you have heard about that, about the word sprint? Perfect, everybody. So who want to go and describe quickly how should it work firstly?
When it's some time, fixed time, with a fixed goal of what should be implemented in this time. And then it is implemented in this time, and before you have a big meeting, and after that you have a big meeting, and if everything is fine, then after the sprint there is an implement to deploy. And in between you have a lot of meetings too, but they should in theory be very quick.
That's true, but that's not an agile. What you described with a meeting structure, there is an approach to that handled by your project manager, your teammate manager. I don't want to use the Scrum term yet, but it is. But the idea of agile is to have the sprints, and on each of the sprints to have some form of predictive approach. So we are planning, we are doing, and only we are evaluating, and we are moving forward. But the sprints should be also in the end of the sprint, you have a already made part of the project. The theory of an agile doesn't require meeting itself. So the idea of agile is just to have this form of loops, each fixed amount of time, but that's it. It doesn't ever specify how the team should communicate with each other. But after some increments to this methodology, there was thing about the flexible approach. So first of all, we need to have a highly professional teams. Preferably, team should be the 2 pizza size. That means that it should be enough to have 2 big pizzas to fit the whole team. Then your team is agile size. In practice, it can be 5 to 12 people, depends on the roles. And these teams are not just software engineers, or if we are talking about building something hardware, it's not just mechanics or hardware engineers. In this amount of people also included your management, your analysis people, and also in this team is highly encouraged to have the cross functionality. That means that then one person is, for example, on a vacation or sick or just planning to leave the company. Every other person in the team kind of aware of that, what that person was in charge of, and they can briefly have this person replaced until the necessary one more person to the team is there. What is also very important is the horizontal organization of the team. Do you understand what does it mean?
Have the same responsibility, and nobody's above others. Everyone is equal.
Yes, but what do you mean under the responsibility?
Everyone has their own subject. Everyone is aware of the other, so nobody have a final vote or something. Like everyone has their own duty.
Yes. So the idea behind that is you don't have a manager inside this team, the person who should say what you need to do. So everybody is planning together, everybody is executing together, and preferably they are also staying in one place. But this information we're taking from the original methodology. After the especially COVID times, everybody understand that everybody can work remotely, and also with a good communication in the team. The team can be situated in every part of the world. So which instruments can be used for this flexible agile methodologies? I've highlighted only 3 of them, but there is much more. First of all, and the biggest is Jira software. This is a software which highly introduced in the companies, especially in the big companies. It's produced by Atlassian software company, and the Jira is the tracker for your tasks, which you have in the original methodology on the board. It also has a lot of nice add-ons, as you can build your Confluence there. It's a knowledge base. You can also add some version control management. You can also synchronize GitHub or GitLab with this software, so your tasks would be nicely tracked itself when you are merging your merge request, and so on. The second one is Redmine. It has a help desk. It's very much a lot of software and tech support departments use it because it has a lot of pre-built workflows for each tasks. And when you're going in the company, where you're doing internship to the tech support, and they're telling you, please first submit a ticket. That's because they use some tracking device in this workflow, and it's nicely calculate how much they were doing during the month, and they mostly using Redmine. And the third and the most easiest way to control your tasks is Trello. First of all, it's much worse than two above, but the biggest support factor here that's it is free. And it's free for everybody, not just a student. It doesn't have a limit for your team, because a lot of softwares have a limit. For example, if your team more than 9 people, please pay us this amount of euro per person. Here is always free of charge, and for managing the student projects or even just your study process, when you're having the sticky notes for each class that you're taking and each assignment that you need to be submitted, you can use it, and it's nice. Let's sum all the approaches up. First of all, after describing all of that, do you think that all the methods can be used together, or one method is significantly better than the other?
Depends on the operation you want to do. But well, for me, I don't like the big one because I think it's like a lot last time that can use for things. So maybe one thing is better, but the rest is okay.
Okay, so here I want to highlight the purpose column. That basically our first marker that we can take a look on if we are looking for speed of the development, or we need to significantly cut the costs. We can take a look at it and choose. We were talking before about the frameworks in general. Now we're gonna take a look in the exact methodologies to each of this approach, and I will also try to bring the information to you that the predictive approach is not the worst one, and you don't have to ignore it all the time. So let's start from waterfall or cascade methodology. This is the representation of predictive approach. And do you think there is some tasks that would be fit perfect to this approach? Once again?
Building a production plant, you should know everything in advance. It's not like you somehow decide to change the product that is produced. So I think very big projects can be done 1 hour. They should be, because it's important to control the cost for its planned.
Here about costs, yeah, that's right. And if we will take the something like putting the spaceship, building it, how many iteration of actually launching it do we have? Yeah. You can try to use any of incremental or iterative approach to the parts of it, but actually set it up to space, you can only once. So here you need to plan everything in advance and only after that execute. And also for the small projects, for example, your whole project is to test one component of the software system. Do you think that you need a lot of iterations or increments in there?
Do what?
You have a whole big software system, and all that you need, your team from one person need to do is to test one component of it.
Could be done in iteration.
And one iteration, do you need all this planning overhead when you can just plan, analyze, and do it? Yeah. So that's why the waterfall or model of the predictive approach is not the worst thing that you can ever imagine. Let's talk about the second approach, is the incremental and iterative approach. Have you seen this V model before? Never? Okay. This is the example of iterative approach. And here, first of all, we are starting our project from here. That means that first of all, we need to have all the information analyzed, all requirements should be set. And after that, you are starting to analyze your system as whole and split it into the tasks for the development. And here our coding happens, and a lot of programmers in their life see only this stage, and they don't know why these requirements and these tasks are formulated this way. But it's never, it's always, they always blame their business analysis, but sometimes this tasks formulated that way because somewhere in the beginning, the customer wasn't very specific about something, and now it should be implemented only in this way. And after the coding is done, we need to start the testing. And the testing should reflect each stage of planning that we have done. And first of all, on the top, only here we are talking with the customer. So they gave out their data, their request, and after that we are talking with them, showing the result. Here also you can see the verification and validation. What do you think there's difference between them?
One is about the requirements you already have, and validation is to check that if they meet those. Like there's this data, and the other one is to check the algorithm.
I guess when we are verifying, it's more about the process of how we are doing, and validation comes at the next part, like when we have already built it and when we need to validate with our previous requirements.
Yeah. So yeah. There is a very easy phrase to remember that basically validation is, are we doing our thing right? And verification, are we even doing the right thing? So when we're talking about the verification, we need to know that we are building that system that we were intended to. Let's talk about the spiral model. This is our incremental approach. As you can see, we are starting somewhere in the middle. And after that, we are going through the planning, development, test, and release stages over and over again. And does somebody want to think how we can build the car in this spiral model? What would be our first stage?
Prototype. See if it works, and then add more detail to it, and more detail, and optimize, and at the end, it released the finished part.
Yeah, so our first prototype can be the small two-wheel scooter with a motor, electrical maybe. Then we are on the second loop of the spiral building already quadro scooter with the 4 wheels. After then, maybe cabrio without a roof. And in the end, we're releasing full car with a roof. So our last iteration is done product, but on the each loop, we had the already ready to ship, ready to market prototype. And now the idea, let's talk about the realization of agile methodology. It's Scrum. And here's all the Scrum meetings and everything that you think of agile happens. This basically was introduced as a management approach. And when we are talking about Scrum, which keywords do you think of?
Meetings.
Meetings?
Daily.
Daily, yeah.
Perspective. Refine them. Good planning.
CI/CD.
I'm not sure that it's related to Scrum. It's related to this project, but Scrum also can be introduced in, for example, event organization. And there is no software, so there's no CI/CD. So it's not really necessary to the Scrum as an approach. None of you have mentioned the whiteboard. But in the initial manifest of Scrum, there was a clearly stated that we need our card sticky notes with tasks, the whiteboard, and the team. So do you all know how the Scrum works? Do you understand this picture, or I need to elaborate on the details? Okay, so let's start with the Scrum roles. Product owner, Scrum master, and Scrum team. How many people is there?
One and 5.
Do you think that the Scrum Master can be the product owner?
No.
Why?
Because those are clearly separated rules, and yeah, I think nobody has the capability. If they do their job right, then they don't have capabilities to do the other as well.
And what is the actual job of Scrum Master then? If the person who is owning the project, who is responding the why question, why we're doing what we're doing, is not the person who is leading all the meetings. Why do we need this Scrum Master?
He ensures that the team can work without disturbances, conflicts, either with the company or the outside, or also on the inside. He also knows the Scrum process or the Agile workflow best. And he can also exchange with other Scrum Masters for frequent problems and their solutions.
And when you're talking about the conflicts in the team, do you think that Scrum team can fight a lot?
I didn't hear the last one. Do you think the Scrum team can
fight a lot between the team members, and why these conflicts can be?
Yeah, they can, because since they are self-organized, nobody's really telling them what to do. So some people might feel the responsibility to tell others what to do, and I think that's also
and yes, and also the key concept of Scrum is sprint and backlogs. What does it mean? Can we, when we are planning which task are we going to take in the next sprint, what happens after? We have a scope in a backlog of 300 tasks which are open and all of them are urgent. We have a team of, for example, 5 people. On which stage we are planning what we're going to take in the next 2 weeks sprint?
the sprint plan.
And what is the limit of how many tasks we can take? Who decide that?
Our team, I guess.
And if the Scrum team decided, they take in the next sprint of 2 weeks, for example, 10 tasks for 5 people, and something crashes in the production. And you have the very urgent bug that should be fixed immediately. Can Scrum team take it according to the pure Scrum methodology? Yeah, that's right. Because it should be planned in a sprint planning. And if something crashed on the day 2 of the sprint, it should wait for 2 weeks. Do you think that's a nice approach to have in a company? Yeah.
Is the Scrum team in general responsible for operations as well?
No, but if you have the whole company of 10 people, 5 of them are developers, and the rest 5 are managers, the managers would pressure the team. Then after this big inconvenience of Scrum with a sprint planning, there is a Kanban. Have you ever heard about the Kanban board? Do you think that's the same board as for Scrum? Do you think that the Kanban is also should use sprints? And does it use it? And in a pure Kanban methodology, we are planning our tasks on a go. So we don't even need sprints if we don't want to. So that means that we can limit our scope of the tasks only based that in progress tasks should be not more than, for example, 10 and not more than 2 for each person. That basically the only thing that limits us. And if we are thinking that the sprints from agile methodology is something that we want to have, we limiting ourselves in tasks only that, okay, something fell from the production and we need to fix it and it's very urgent. We are throwing something back to the backlog from in progress and taking this urgent stuff at any time we need. And this approach is mostly used in the companies, and a lot of people think that is a Scrum, but it's not. So to compare them more in a less abstract words, that the Scrum is a bus. It stops only on dedicated spots. On a bus stops, you have a very strict specified roles, and your iteration is fixed by the sprint. You don't have any limit of and restriction of how many tasks you want to take. But everything what happened between the sprint plannings is over the scope for the next 2 weeks. When we are talking about the Kanban, it's more like a taxi or a lift ride. So there is some predefined way where this car goes, but you can jump in and jump out at any time you want. So you can take the task anytime. Also, you can release task also anytime. When we are talking about the limitation on something work in progress, there is only limit for tasks which can be open, and that's it. There is no roles predefined, so the team actually manage itself without any Scrum Master. Everything holds on the pure communication between the team members. Do you think that there's no more methodology for Agile? There's also the thing called Scrumban. This is the methodology mostly used in a company because a lot of the management somehow, some way before, heard about Agile, about Kanban, about Scrum, and then just combined everything together and decided to, okay, now we will call it Scrum and we will work like this. So technically, it's a different methodology when they are taking what they want from each, but mostly it happens that you have sprints, you have a board, you have assigned roles, but you don't have this sprint planning when you take nothing in between the sprints. You usually take these urgent issues and use the Kanban visualization with this board, but with the Scrum processes. Now let's discuss this thing that you are facing as a AI students. For example, you have a task for you have this data that somebody, a manager from the store, comes to you and say, okay, I have the data about my customers. There's gender, age, frequency of purchases, some products that they recently bought, and I want to do something with this data. And this is your technical requirement. So your question is, what machine learning technique can be applied to solve this problem? How you as a software engineering team would pursue this task?
Divided into some steps like data analysis,
Mhm.
then model exploration, like build a very simple model or different simple models and compare them, look in which direction it might go, then further pursue the best
Mhm.
one or two models.
But when you have this variation of models, for example, KNN, neural networks, random forest, for example, even these three, implementation of each takes time, and this time your customer is paying you. And do you think that your data experiments have also always accuracy above the 90%?
Accuracy about
More than 90%. So, for example, you've built a neural network and your accuracy is 15%. It doesn't work. But this is the reality of data science. Can you move these tasks to done? Is it actually done? Not really, but can you close it as nothing had happened when you spend 40 hours on that?
Isn't it possible to do this with less effort, like just to try it out once, twice? There are a lot of libraries you can use to really quickly implement such a model.
It's possible, but when you're using the project management, for example, as a Scrum bun, you have your tasks on the board where you need to put your card with this implement random forest when it crashes. But won't do means that you haven't spent any time. And for the customer, it looks like he or she pays you and nothing have happened.
I think I would change the number, the description of the task as to explore models or compare models, something like that. And then you can say, okay, I've tried 3 models. This one was the best, the other 2 didn't work. And then can show the customer that you've actually done something.
I like your idea about the showing to the customer that you've tried something. And for that, there is a special methodology for data science called Lean DS. The idea behind it is that you are formulating the hypothesis and not the tasks with the customer. That basically means that you are trying to formulate hypothesis as a, we will try this to improve this, and your customer have a very active part in it. So they also see that the team is working. They're not paying for just waiting. And it encourages them to trust the process. So how the hypotheses look like? You have 3 types of hypothesis. First of all is the product hypothesis. That's basically an assumption that what we can change to bring the value to the business, to the customer. The data hypothesis is the assumption of how we can improve our existing data, add something, delete something, clear something. And the method hypothesis, this is the hypothesis about how we can change the method. And all our hypotheses is always look like this. So we believe that we will solve the problem. Here there's a problem for the audience, so for the customer. And to do that, we will make some change, and we will be right if there is some criteria is met. So let's try to build this hypothesis for the existing problem.
We believe we will be able to predict to predict which customers are most likely to repeat purchases in the next month. For the online store, to do that, we will try model X, Y, and Z. And we will be right if we get an accuracy of over 90%.
Yep. So my idea was pretty similar. So we believe that we will reduce the cost of agents, so the consultants in the store, serving for the mass segment for the customer. And to do this, we will automatically categorize the customers, and we will be right if we will increase the number of customers serving by an agent by 10%. So only thing that is not the same as you've said in your hypothesis is that our results should be clear for the customer, because this person is not always the computer science and they need to see the value of what are you doing. Only then they will like to pay you.
That means that you actually have to deploy it in the store, and that takes time again. So
yeah,
just planning over longer.
It's still better than you're doing something for a month, you're deploying it, it doesn't work, and you need to start something from scratch. And the idea here is the customer usually they're not always loyal to you they don't trust you as a team. And the idea behind the hypothesis that's we should make only atomic changes. So we either change the methods or we change the data. So we cannot say that we will take more data from the customer about something, and after that also use the different methods to increase something. And this can lead to the problem, because then you don't know what brought you to your success or failure. So all your changes in this hypothesis should be very atomic. And the huge benefit here is that you have a very high inclusion of your customer. Your team is seeing that they are not standing on the same spot, they are moving. And for the project visualization, it's also nice that you don't have a lot of tasks closes won't be done, would not do it, and so on. Do you see yourself in this situation? A lot of the times when you're studying. When you're starting something and then you have a different idea and a lot of your side project is not finished. I think yes. And why does it happen in the study world? It's basically because Even the small project needs to be managed. And all these company approaches not always work for the team of 4 friends, for example. And here there is a nice technique that you can play around while you're still studying, is the extreme programming. It's not the programming when you're hanging upside down or riding the Autobahn 200 kilometers per hour. This is basically the combination of all the approaches which exist on their pretty best. And it's always simple, always a lot of communication and feedback. And when you are the team of 4 people without a lot of management overhead and a lot of deliverables, you can try everything from here. But also there is a lot of disadvantages. Basically, if you're using it with a study project with a professor, you need a lot of regular meetings to define your path. And it's not suitable when you want to scale. Have you ever heard about this practice of pair programming? Have you ever tried it? And which one of these 2 approaches for the pair programming is when one person is having the general idea and the second person is coding it? Or you've tried the test-driven development, or one person writes the test, second write the code?
More number 1.
Do you think which advantages from this approach you can name?
It's really divide your responsibilities. You can stay in your domain. So the one is really familiar with the programming language, and the other one with the problem domain, and splitting it up. By splitting it up, everybody can concentrate more on a specific domain and get better results.
Yeah, and I want to pay your attention on the thing called buzz factor. Have anybody heard about that before? Is this term new? No? It's new for somebody, so I will explain. This term became popular after the, I think, creator of the Python language was on a conference and was asked by his colleagues what would happen with a Python if this person would just exit the building and gonna be hit by a bus. And the idea behind that if everything, all the information is just in one head of one person, after this person would leave the company, get sick for a long time, or unfortunately die in a very unclear circumstances in one moment, the project can be lost. So when you're doing your pair programming, the second person is always aware of what's going on, and you're closing this. If one of you would decide to leave the project, everything would not be just a weird code. But here's a lot of disadvantages. Basically, it is very expensive because you need 2 people for do 1-person job. And it's difficult to change the partners after a lot of projects together. And also this is resource intensive. Next approach from the scope of extreme programming, this is a test-driven development. This approach became more popular after the GPT was released as a technology, when you can try to prompt the tests for your software, and after for these tests, write the code. An idea here that we are first of all writing tests, and then implementing everything until it's basically passed these tests. And only after that we are moving forward. And as the outcomes that I want to bring out of this lecture, first of all, that you need to find that product that would work for you. And if you're working, joining some team, for example, in a company, don't interfere with their processes. It took their pretty long time to settle it. Just acknowledge it and move forward with your internship. And also I think that a lot of you thought why you've spent 1.5 hours listening about management when you are computer scientists. That's basically the answer here, that you need to understand these processes to be successful in the companies, in the corporates, because just lonely programmer in the corner is something that has already passed a couple decades ago. Now everybody's working on a team, and this team should be managed. And also I brought some ideas for your final project for this semester. You can take a picture if you want. So there is some more methodologies about management, some practices on the deployment as safe, and some AI-based code write assistants. And if you want to have some additional ideas, you always can email me anytime. Thank you.